This video demonstrates a novel approach for enhancing the visual readability of 3D urban maps. The main idea of our approach is to avoid occlusion of geographic landmarks by suppressing the building heights as well as displacing roads and buildings. For this purpose, we formulate 5 aesthetic criteria as constraints and solve it as a constraint optimization problem by employing linear programming techniques. The originality of the proposed approach is that it allows us to quantify spatial displacements of geographic features as a cost and optimizing under constraint for disoccluding important landmarks. Employing this mathematical formulation allows us to automatically optimize the map deformation, and thus requires minimal user intervention for finding visually plausible layouts of 3D urban maps. In this clip, we demonstrate how we can deform 3D urban maps by using our prototype system. First, we can select specific road by clicking on the roads using a mouse, where selecting roads are marked in orange. We can also choose an elevation angle and then start the deformation process. As you can see here, the roads are horizontally displaced and buildings are vertically suppressed in order to avoid undesirable occlusion over the map domain. We can also select various types of routes as landmarks and try to disocclude these routes with our system. This is an example where a long and sharply curved route is specified as a landmark in a dense urban environment. This demonstrates that all the routes are made visible through the constraint optimization process. In our system, we can specify important buildings as landmarks. In this example, the landmark building in white colors are enlarged so that they can visually pop up from the optimized map layout. Furthermore, we can also annotate important roads with their name on the map. As you can see here, the surrounding buildings and roads are rearranged to spare additional spaces around the roads to be annotated, for improving visual clarity through the deformation process. In our system, the map deformation is controlled by adjusting the weight assigned to each coast turn, so that we can find a different compromise between the displacement of geographic features and the penalty of landmark occlusion. The clip shows a comparison between the map layout optimized with different weight values. This result shows that our system successfully avoids occlusions of landmarks by aggressively suppressing the height of buildings. By increasing the weight for the vertical displacements of buildings, we can maximally retain their original heights while relaxing the horizontal displacements instead to alleviate the occlusion problem. The following clip shows optimized 3D urban maps with different angles of elevation. This shows an example with angle of 60 degrees. This shows an example with angle of 40 degrees. This shows an example with angle of 20 degrees, which shows that our approach still works well with different angles of elevation. We extend our approach so that we can also avoid the occlusion of landmark buildings instead of roads. This clip shows the result before and after the optimization process. As you can see, the specified landmark building becomes clearly visible after the deformation process by avoiding occlusions from the surrounding high buildings. To demonstrate the feasibility of our approach, we organize an eye-tracking experiment to check whether the disoccluded routes attract map users' visual attention. This clip shows the comparison between eye gaze distribution over ordinary perspective view of a 3D urban environment and its optimized version. An eye gaze movement example of the map users here demonstrates exactly how they focus on the routes of our map.